Good day, students. Welcome to math.serve.com. In this clip, we're going to be continuing our work on applications on differentiation, part 3, problems 7 to 10. This should help you with chapter 3, section 1 of the Larson AP Calculus textbooks, problems 7 to 10 also. The instructions are as follows. We are to identify the critical numbers of the functions with the graphs presented below, and then proceed to describe the extrema, stating if they are relative max or min, and if they are absolute max or min. Okay? Alright, so before we start with number 7, let's go ahead and do a real quick review on the definition of what critical numbers are. Okay? So, in brief, critical numbers are basically points in the domain of a function where the derivative is equal to 0 or non-existent. Okay, so critical numbers are points where f prime of x is equal to 0 or f prime of x does not exist. Okay, so you can think about critical numbers using tangent lines. Alright, so critical numbers are places where you have horizontal tangents. We're going to call that hortan. Or you have a vertical tangent, vertan, or you have no tangent line at all, no tan. Okay, so when you think about critical numbers, think about hortan, vertan, or no tan. What do horizontal tangents look like? Horizontal tangents happen where you have a point on a peak or valley where the function is smooth and continuous on that peak or valley. Okay, so let's look at an example of a valley. So this is a function that's smooth and continuous. At the valley point, you have a horizontal tangent line there. So that basically makes that point, that low point, a critical number. The x value makes it a critical number. Alright, so I have a critical number there. For vertical tangent line, you basically have a situation where your tangent line to the curve is vertical. Alright, so if you have a function that looks something like this, and somewhere here you have a vertical line that's tangent, the tangent line to the graph is basically vertical. And what do you know about the slope of a vertical line? The slope of a vertical line is undefined, right? So whenever you have a vertical tangent line, that is one of the cases where the derivative does not exist. How about no tan? You have no tan where you have a corner or a cusp. Okay? You also have the non-existence of tangent lines at discontinuities. So for critical number, if we're looking at continuous functions, we're just going to restrict ourselves to scenarios where you have a cusp or you have a corner. Okay, so these are critical numbers, but the tangent line is not defined for any of these cases. Alright, so these are the cases we're going to be looking at for this set of problems. Let's take a look at number 7. We're going to identify the critical numbers. The critical numbers are points where the derivative is equal to 0 or does not exist. Alright, so if you look at this function right here, you have an extrema here, namely a minimum, and the graph is smooth and continuous on this point. Basically, there's nothing funny happening here. You don't have a corner or a cusp. It's smooth, so we know for sure that there is a horizontal tangent line here. Okay, so the question is, what is the x value where you have this horizontal tangent line? So this is 1, 2, 3. So this value right here, at x equals 3, this is a critical number. Alright, so in this particular problem, our critical number is that x equals 3. Why is that a critical number? Let's justify our reason. This is since the derivative f prime of 3 is what? F prime of 3 is equal to 0. And that's one of the cases where you have a critical number. F prime of 3 equals 0. Alright, now how about extrema? Let's describe the extrema here. This is a low point, so it's automatically a relative min. Alright, and then if you look at this function, is the lowest point on the entire function. So it's also your absolute minimum too. Alright, so what do we have at this critical number? We have a relative minimum at x equals 3. And we also have an absolute minimum. Okay, remember, all absolute extrema are also relative extrema too. Alright, so at x equals 3, but not all relative extrema are absolute. So that's that for question number 7. Now, just a side point to note, one might argue, what about these endpoints right here? They're high points. Relatively speaking, they're maximums, right? But why didn't we include them as relative or absolute maximums? That's the question. So, side note, something to note is that x equals 1 and x equals, so this is 3, 4, 5. These points are not extremas. Why? Why are they not extremas? They are not extremas because they're open circles. They're not extremas because they are excluded from the domain. Okay, they are excluded from the domain of the function. They are excluded from the domain of f. So if an extrema, a point where an extrema exists is an open circle, then that extrema is not considered as part of the function. Hence, you cannot list it as a relative max or min. Okay, so you have endpoints here. That means that we have these 2 points do not count as absolute or relative extrema because of their exclusion. All right, let's take a look at problem number 8. So let's look at this graph right here. So the question here is, what are the critical numbers for this graph that we have right here? So remember, critical numbers are basically where the derivative is equal to 0 or non-existent. Okay, so for this particular problem, the critical number is at where? It's going to be at x equals 1. Why is that? Well, at x equals 1, you have a horizontal tangent line. Okay, at this particular point, f prime of 1 is equal to 0. You have a horizontal tangent line. Remember, for critical points, you have either hortan, notan, or vertan. We have a hortan here, so at this point of tangency, you have a critical number. So critical number is going to be at x equals 0. No, x equals 1. Why is a critical number at x equals 1? Well, since the derivative at that particular value is equal to 1, basically representing a horizontal tangent line. Okay? Now, how about our relative extremas, relative mean or max? So, relative mean or max. Do you have any relative mean or max here? The answer is no, there are none. Alright? The endpoints could have been relative extremas, but they are excluded from the domain of the function. Hence, we don't have the endpoints as min or maxes. And at the interior, you do not have any peaks or valleys on the interior of the function. So there are no relative min or max. So since we have no relative min or max, how about absolute? There are none. Okay? There are absolute min or max are none also. You can have an absolute without having a relative because remember, all absolute extremas are relative extremas also. Alright, let's take a look at question 9. We have this strange looking function here. Now, what are the critical numbers? Critical numbers are points where the derivative is equal to 0 or does not exist. Can you identify what the critical numbers are? The critical numbers are at x equals 0, 1, and 2. Bam. So you have a critical number here, you have a critical number here, you have a critical number there. Why? Well, this is the reason, since f prime of 0 is the same thing as f prime of 2. At x equals 0 and 2, you have a horizontal tangent line. Okay? So we have a hortan situation. And then at 1, what's happening there? At 1, we have a cusp. F prime of 1 does not exist. So we have a no tan situation. Okay? So there goes your critical numbers. Let's go ahead and illustrate them in the graph. So for at 0 and 2, we have horizontal tangent lines. Okay? But at 1, there is no tangent line there. Alright, so here we have f prime of 2. The slope of the tangent line is horizontal, so 0. And then here, at this point, f prime of 0 is equal to 0. Over here we have a cusp. So at a cusp, you cannot draw a tangent line. F prime of 1 does not exist. Okay? So this is no tan. This here is a horizontal tangent line. Let's just call it hortan. And this is another hortan right here. So these are the 3 critical numbers for this function on the domain from -1 all the way to 3. Okay, now let's go ahead and indicate the extremas. Let's start with the relative first. Okay, so we have a relative min at x equals 0 and x equals 2. We see that those are minimized because they're valleys, they're low points in this function. And then relative maximum is going to be at x equals 1 because that's a peak right there. Alrighty. Now, remember, endpoints are open circles, so we don't look at them. How about absolute? In this function, we have absolute minimum at x equals 0 and x equals 2. Okay, we see that they are absolute minimum because these are the lowest points on the entire domain. How about absolute max? X equals 1 is a relative max, but is this the highest output in this function? The answer is no. This function does not have an absolute max because the relative max that we selected is lower than some points on the graph and the endpoints are opened. The endpoints should be the maxima, but they're open. They're not included. So the absolute maximum here is none. You have no absolute max for this particular function. All right, let's take a look at question number 10. Now, what are the critical values here? Critical numbers. So let's go ahead and write it down. Critical numbers are at x equals, so we're looking for where we have vertical tangent, no tangent lines, or horizontal tangents in the domain from -1 to 4, excluding the endpoints. We have critical numbers at x equals 0 and x equals 2. Do you see why those are critical numbers? It is because we have horizontal tangents at those 2 points. So here we have a horizontal tangent, and then here also we have a horizontal tangent. So those are the 2 cases where you have critical numbers. So you have a critical number there and then a critical number there. Those are the only 2 critical numbers that we have in the domain of this function. All right, so let's write down our justification. Since f prime of 0 is the same thing as f prime of 2, they're both horizontal tangent lines, so their slope is equal to 0. This is a horizontal tangent type scenario. All right, so here f prime of 2 is 0, and then here f prime of 0 is 0 also. All right, so in both cases we have horizontal tangent lines. All right, so that's all the critical numbers. Those are all the critical numbers for this graph. Now let's take a look at the relative extrema. Let's start with minimum first. Relative minimum. Relative minimum is going to be at x equals 2. Wait a minute. What about x equals 0? This is a critical number, but it's not a relative min because it's not a low point in the neighborhood. Okay, so that should tell you something. Not all critical numbers are extremas. Some of them are faker. They're fake. Okay, you think they're critical you think that they're an extrema, but they're not. So this one was acting kind of sort of like a minimum, but it wasn't a minimum because the function decreased to that. It looks like it was going to turn and go up, which would make it a minimum, but it just continued going down after attaining a horizontal point of tangency. All right, so you have to be really careful when you're looking for extremas to make sure that just note that not all critical numbers are absolute or relative extrema. All right, so the only real extrema we have here is at 2 because the function descended to that point and then reversed behavior and started increasing. All right, so you have a decrease into that point and it starts increasing, which makes it a relative minimum. As opposed to this case, it decreases to that point, stops for a second, and then continues decreasing, which does not make it an extrema of any kind. All right, so we have the relative minimum for this problem. As for relative maximum, there are no high points. The high points would have been the endpoints, but they are excluded, so relative max is none. How about absolute minimum? In this graph, we have only one absolute minimum. Is that at x equals 2, the same point where the relative min is at, because this is the lowest point in the entire domain of this function. For absolute max, guess what? Since we have no relative max, there is no way we're going to have an absolute maximum. Okay, because all absolute extrema are relative extremas also. So if you don't have any relative, you're guaranteed not to have any absolutes. Okay, so that's that for question number 10. Alright, so how well did you understand what we just covered in this presentation? You can take a look at Larson, section 3.1. And I'd like you to try out problems number 7 to 10 and see how well you do in demonstrating your understanding of finding the critical numbers and extremas of a function given the graph. Thanks so much for taking the time to watch this presentation. Really appreciate it. Don't forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions or comments, just place it in the comment section below, and we will be more than glad to support you. More great resources for your study of AP Calc can be found on mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.